Question number 6. The decreasing order of radii of the species O, O2 minus, F, F minus, S2 minus, Cl minus is. Now, the radii of a species depends on several factors. Factors affecting the radii. These factors are, first one, the number of energy levels, number of shells. Second one, the charge of the species. Third one, effective nuclear charge. Effective nuclear charge, Z star. Fourth one, number of electrons. Right. Now let's compare this number of shells. If you want to find the number of shells, we have to write down the electronic configurations of all these species. Therefore, for oxide, first oxygen atomic number is 8. Its electron configuration will be 1s2, 2s2, 2p4. O2 minus will be 1s2, 2s2, 2p6. Fluorine is 9, 1s2, 2s2, 2p5. F minus 1s2, 2s2, 2p6. Sulfide S2 minus, it's 16, 1s2, 2s2, 2p6, 3s2, 3p6, and chloride, it's 17, 1s2, 2s2, 2p6, 3s2, 3p6. Right, by looking at the electronic configurations, we can see that sulfide and chloride have more energy levels, therefore those two have the greatest radii. So we can categorize them like this. Sulfide and chloride, they have the highest radii. The others have the lower radii. Oxygen, O2 minus, F minus. Right. Now from sulfide and chloride, to find the radii order, we have to go for the next point, the charge of the species. Now both of them have the same charge. Now when you consider the charge of the species, negative ions have the highest radius, then neutral atoms, then positive ions. When you consider the sulfide and chloride, both of them are negative ions, therefore we can't use the second point, so we have to go for the third point. So let's find out the effective nuclear charges of all these species. Right. The effective nuclear charge is calculated using this equation. Effective nuclear charge is equal to the actual nuclear charge minus the shielding effect. Now generally in the advanced level, we don't calculate the actual shielding effect, we are just calculating a closer value to the shielding effect. The calculated value is slightly higher than the actual effective nuclear charge, therefore please remember that whatever the value that we get from calculating the effective nuclear charge should be a smaller value than the calculated value. All right, so let's calculate for the oxygen. It should be 8 minus the shielding effect. As the shielding effect, we take the inner shell electrons, so the inner shell will be 2 here. So let's first mark all the inner shells. Since second energy level is the valence shell or the last energy level, the inner shell will be the first one. So use that argument, same argument for all the species. So I'm going to highlight the inner shells. Try to understand this. This will be the inner shell here, this one, and the sulfide and chloride, their last shell is the third one. Therefore both of these are inner shells. So we have to subtract the number of inner shell electrons as the shielding effect. Now in oxygen it's 2, therefore it will be 6. The effective nuclear charge of oxygen will be 6. The effective nuclear charge of oxide is also the same here. It's also 6. For fluorine it's 9 minus 2, 7. 9 minus 2, 7. For sulfide it's 16 minus 10. It will be 6. For chlorine it's 17 minus 10. It's 7. Right. When we compare the effective nuclear charges of sulfide and chloride, we are comparing these two. Chloride has the higher effective nuclear charge, since when the effective nuclear charge become higher, the radius become smaller. Therefore the largest ion will be sulfide. So sulfide is larger than chloride. All right. Now we have to choose from these 4. Now when we compare oxygen, oxide, fluorine, fluoride, we can categorize them into 2 different groups using the charge of the species. Now these 4 have 2 charged part molecules. Those are 2 charged ions actually, oxide and fluoride. So oxide, fluoride, we don't know which one is greater, and neutral atoms should have a smaller radius. I think you can understand. Then from oxide and fluoride we have to choose. For that we have to go for the third point, effective nuclear charge. Now you can't change this order. If you change this order, you will get a wrong answer. So you have to exactly follow this order. First you have to look out for the number of shells, then look for the charge of the species, then the effective nuclear charge, and finally if you can't find the actual order using these first 3 points, then go for the last point, the number of electrons. Okay, now if we apply the third point here, the effective nuclear charge of oxide and fluoride. So we are comparing this and this. The effective nuclear charge is greater in oxide ion, therefore its radius will be greater. So the order will be sulfide, chloride, oxide, fluoride. The same argument can be used for oxygen and fluorine. If you look at here, effective nuclear charge of oxygen is smaller, therefore its radius is greater. Therefore oxygen and fluorine. So this will be the answer. Now this categorization is done using the number of shells. This categorization is done using the charge of the species. Now finally, effective nuclear charge. Alright, so let's look at the answers. It should be the first one. Yes, right, the answer is the first one. Now let's go for the next question.